Howdy everybody, I'm Ken Fisher and this is Demystifying Dynamic Sql. So let's start with a little housekeeping. Pass, this is a Pass event. This is the very first virtual Pass summit. Hope everybody's staying safe. This is by no means all that Pass has to offer. There are lots of free resources available. There are some that you have to pay for, but even those are quite worth it. If you've never been to a Sql Saturday, as soon as this whole pandemic thing is over, I highly recommend it. They're a lot of fun, a lot of free training, and a lot of great friends that you maybe have met, maybe you haven't. It's worth getting a Pass account. It's worth taking a look and seeing what they have to offer. Evaluations. As a speaker, I love evaluations. I want your opinion on how good or bad a job I did. Give me some constructive criticism. Let me know what I can do better next time. Okay, a little bit about me. I am Kenneth Fisher. I've been a data platform MVP for a few years now. I've been a DBA pretty much my entire career of pushing 30 years now, I guess. You may have seen my blog, sqlstudies.com. Feel free to leave a comment, say hello. Feel free to email me at sqlstudent144@gmail.com. I'm not great at responding to email, so you're probably better off finding me on Twitter. I'm at sqlstudent144. I'm there most of the time. Just ask my wife. So you may notice a theme here. I do give homework, and there will be a quiz at the end. Okay, so what exactly is Dynamic Sql? Simply enough, Dynamic Sql is using code to build SQL code. It might be C# building T-SQL. It might be T-SQL building T-SQL. It could be Python building PL/SQL. Doesn't matter. And most of the stuff that I'm going to talk about today will be useful regardless. Now, for most of us, we're using T-SQL to T-SQL. So what's the point in Dynamic Sql? Why do we want to use it? It's powerful. It can do things that you just can't do with normal SQL code. There are places where you can dramatically improve your performance. You get unparalleled flexibility. You can create code that you just can't do any other way. And when you get to automation, if you're using SQL, not something like PowerShell, then you're going to want to use Dynamic Sql. Obviously, I'm a big fan of Dynamic Sql, but I'm somewhat unusual in that respect. A lot of people don't like Dynamic Sql. Why not? Well, it's complicated. Dynamic Sql is easy to get wrong. It breaks with small changes in the data. And those small changes can have huge consequences just by the nature of where we use Dynamic Sql. Then there's Sql Injection. And honestly, Sql Injection is probably the best reason for not using Dynamic Sql. Sql Injection is where someone takes their SQL code and slips it into yours. And they may be looking at your data, they may be changing your data, deleting your data. Basically, anything you have permissions to do, they can do. There are a couple of different types of Dynamic SQL, at least as far as I'm concerned. And I break them down as one-to-many and many-to-one. One-to-many is where you use a single query to create a bunch of commands. For example, you're modifying a property on all of the databases on your instance. This is mostly going to be done by DBAs, by administrators. The commands are either going to be copied out and pasted into a new window or possibly run through some type of a loop. Yes, cursors. It's typically done for maintenance, admin work, that kind of thing. Then there's many-to-one. Now, many-to-one is where you're using a bunch of commands to generate a single piece of SQL code for a single purpose. Usually this is going to be done by developers to create a command to run for the application. You can use this to replace the values in an in clause or pieces of a where clause, that kind of thing. All right, the rest of the presentation is going to be demos with a few slides mixed in just for fun. So let's get to it. Okay, all of my demo scripts have been uploaded to the Summit site, so you should be able to get them pretty easily if you want to follow along or if you want to try this again later. To help with that, script 0 is a setup script. It changes AdventureWorks to compatibility level 110, creates a couple of spare databases, some logins, add some objects to one of those databases, etc. It's a pretty simple script. As with all scripts, if you're going to run it on your machine, make sure you look at it before you do anything. Now, what isn't quite so simple, this is an example of some dynamic SQL that I've written. This is a store procedure that allows you to do research on logins and server level roles and stuff like that. And you'll notice the dynamic SQL here is somewhat complicated. And I'll be honest with you, it's complicated for me too. But we're not going to mess with anything this difficult. We're going to start with doing an altered database. Let's go ahead and expand this a little bit to make it easier to read. All right, so when you're doing one-to-many dynamic SQL, again, we're using a single command to generate multiple SQL statements. The first thing we're going to do is we're going to write our SQL statement, which in this case is to change a single database to compatibility level 130. All right, so that's the very first thing you do. You always write your SQL statement first. Now, in this case, because this is one-to-many, we're also going to write the query that is going to pull the data that we want to run that query on. So in this case, we're updating all databases on my instance to be compatibility level 130 or higher. So we're going to check for any databases that are under 130, and we'll run that. And again, you build this, okay? You're going to build your dynamic SQL a piece at a time. So in this case, I've got 3 databases that need to be updated. Now, once we have these 2 pieces done, we're going to take our code that we want to run, and we're going to replace the star. Okay? Very first thing we do. Now, we're going to put quotes around it. We're going to turn it into a string using single quotes. Next step, we're going to convert any literals to fields. All right, and we're going to do that by replacing it with 2 single quotes, back up, 2 plus signs, back up, and now we're going to put name, which is the column that we want to change. Okay, so we want to put name of the database in that statement. Simple enough. All right, now if I run this, I'll get this. And that's great. All right. So I'm going to take this, and you always want to test. Always, always, always test. So we're going to take these and we're going to paste them, and we're going to try running them. And let's run this one. Oh no, I got an error. Now, I want to point out, I'm doing a lot of typing here. They say never type in your demos. if I make mistakes, if you see errors, it's deliberate. Every mistake I make is intentional. It's to prove a point. So there won't be any mistakes that are not planned. Now, the problem here, you'll notice, I'm doing an alter database on a really funky looking database name. It could be worse. It could be a SharePoint database that's a good. But regardless, this obviously is not correct. What it needs to have is brackets around it. Now, if I put brackets around it, and I'm not actually going to run it, but I'm going to hit the checkbox, I'm going to get a successful. So to put the brackets around it, now I could, if I wanted, put brackets here, like this. But rather than do that, get into the habit of always putting quote name around your fields that you do like this. Now, what that's going to do is that's going to, by default, put the brackets on either side. And if there happens to be a bracket on the inside of your name, so the object name happens to have a bracket in it, it's going to do what's called escaping it. And we'll get into what escaping is in a little bit. So again, we're going to test it. We're going to take it. We're going to copy it into another window. We're going to parse it. And it parses successfully. So the next step is we run it. Now, I recommend always running one statement. Make sure it worked. Great. Now I can go ahead and run the rest of them. Like that. Okay. Okay. We're going to do another one-to-many. Practice is always a good idea, right? And again, I've got my instructions at the top here on how to build a dynamic SQL statement. These are my processes. You certainly don't have to use them, so take it for what it's worth. But the first thing we do is we write our SQL statement. First, we just start over. All right, we're going to do another one-to-many. We're actually going to do something that I've had to do for work in the past. We are going to add a modified date to every table that doesn't already have one. And while we're at it, we're going to go ahead and add a default constraint of get date to each of those columns. So the first thing we do is we write the SQL statement and the query that pulls the result set. I've got those down here. Alter classes to add the modified date and query against information schema.tables. I happen to like information schema for these types of queries. You could certainly use sys.tables and sys.columns. I just find this easy to read for a demo. So I run my queries to make sure that I'm doing this right. Because you never know when you're going to make a mistake. Dynamic SQL is really complicated. You need to build and test, add little pieces over and over, and test every time to make sure you get each piece correct. So as an example, I've got a problem here. Okay, I'm not going to add a column to a view, at least not directly. So I need to make a point of adding and t.table type equals base table. Now, when I run this, I only get tables. All right, so next step, step 3, we're going to add the command to the query, convert it to a string. Now, a lot of people would like to add a quote to the beginning of each line, and then quotes to the end of each line. Now each line is its own string. We add a carriage return to the end here, another plus. and we have a multi-line string. That's how I used to do it. I've found that with really complicated queries, large queries, it gets kind of cluttered looking, and I don't find it as easy to read. So I don't do that anymore. I go ahead and just put quotes on either end of it. Now, there are no ticks in here, no single quotes, so I don't need to do anything there. I am, however, now going to replace classes, add 2 ticks, 2 pluses. We're going to go ahead and put in a quote name, t.table name. All right, and we're going to run it. All right, very cool. Now, let's grab a few of these, come over here, and notice that I've got my character turn. They look pretty good. See? So we're going to go ahead and hit check. All looks good. All right, so having done this once, we can just go ahead and copy this, and we're going to replace the other time we've got the table name here. And let's pull it out. And let's put it over here to look at. And I don't know about you, but I don't like this. So here's the thing. For names like this, you don't want to put quote name in the middle, but you do need quote name because this is not going to work without the brackets. So what we're going to do instead is we're going to move quote name over here. And we have to take it apart, make the string. So like this, and again, quote, quote, plus, plus. Well, actually, yeah. And then that. And now, when I run it, get an error. Okay, let's see. Again, this is an example of why we need to test over and over again. Obviously, we do not need that plus there. Over here, yay. So now we put that in there. All right, and let's check it. And beautiful. Okay, now let's go ahead and run it. Oh, we got an error. No object called employees. Well, that's a problem. You know what we forgot? We forgot that some of these tables have schemas. And the easy way to check that is to go ahead and go over here. Rather than undoing what we've done, we'll just add a select star and get rid of that. And if you look, employees is actually in a schema called administration. So the way to fix that is we come over here, and again, we need to use quote name because we don't know what people are naming these things. All right, and we add, if I just run this, that's not right, right? So we need to remember to put the period, which is, of course, a string. And lo and behold. Now, you'll notice I didn't add the schema to the name of the constraint. I find that to be annoying, and it's unnecessary, so I just left it out. But let's test again, okay? We'll run this employees one, and lo and behold, it worked. So now we can run the rest. No problem, right? Okay, this time we're going to try something a little different. we're going to take a select statement and change the from clause, the table in the from clause, to a variable. If you recall, I said that dynamic SQL can do things that regular SQL just can't. So for example, simple select statement, if we change it to this, where we declare a table name and we store sys.databases in that variable, and then try to do a select on that variable name, we're going to get an error. The only way this would work, this particular statement would work, is if at table name or a table variable. So what are we going to do? We are going to create a many-to-one dynamic SQL. Now remember, this is where we take multiple statements and use them to create a single statement. All right, simple enough. The first thing we do is we create our piece of code, which we've done, right? Select star from sys.databases. The next thing we do is we declare a variable to store the code in and convert the code to a string. So we're going to cut that. We're going to paste it into our string here. Next thing we do is convert any literals into a field. Now to do that, we'll need a variable. So we're going to go ahead and grab our table name variable. Now I'm a little lazy here, and I'm using just table name. Really, if you were to be doing this at work, you'd want to have a table name and a schema name, and you'd want to put quote name around them both, but I'm not in this case. So, because I am a bad lazy DBA. So what I'm going to do is I'm going to replace sys.databases, double quotes, double pluses, and the variable at table name. And when I run this, notice I've got a print here. One of the things you always want to do is print your code out to test. So notice I can go ahead and take this, copy it, and put it over here and try it, and it works just fine. Now, obviously we don't want to do that within our code. If we're actually writing something to run, we're going to want to run it. So we'll use something called Execute Sql. All right, and that will run our SQL code. So now, when I try running this, it works. All right, why is it bad that I didn't put quote name here? Very simple. What if the value passed into the table name looked like this? Now, when I run my code, I get my list of databases just like I expected, but I also get a list of all the tables. And now the person who went ahead and passed in sys.databases semicolon select star from sys.tables semicolon can look at, well, any of these tables. They could look at sys.employees, dbo.employees, or payroll, or whatever, and make changes and do whatever they want. This is what we talked about earlier called Sql Injection. All right, this is, again, probably the biggest reason not to use dynamic SQL, but it's also perfectly solvable. Okay, we throw a quote name around this. Now when we run this, we're going to get an error because that's not a valid object. Okay, let's go back and print it out again real quick so that we can see what it looks like. And the reason it showed up that way, the reason we got that error, is because we put brackets around the name. So this becomes a single literal instead of two statements. As soon as these brackets go away, SQL actually interprets it as these two statements. Real quick, I want to talk about an important concept called escaping. This is not a concept that's unique to SQL. It is, however, very important when it comes to dynamic SQL. Escaping is based on the fact that computers are stupid. People are really good at pattern recognition. Computers, not so much. They're getting better, don't get me wrong, but computers are always going to be very literal about what they see. People are able to make judgments and use far more information when it comes to deciding if something is a pattern. So let me give you some examples of how this works for a computer and a person. So this is how we would see this string. It's a single string with a quote in the middle of it. To a computer, you have the begin string, the end string quotes, and then you have an extra one at the end to start the next string. And here's an example of the same problem, only with C# and with HTML, where again, the computer doesn't understand where we intended the beginning and the end of the string or the comment to be. Because of this, we need to give the computer a little extra help. We need to specify which character is actually the end of the boundary and which one isn't. And this process is called escaping. In the case of T-SQL, you'll notice doubling quotes. C# using backslashes. And in HTML, we replace various characters with combinations of characters. Now, when it comes to escaping in SQL, there are a couple of ways to handle it. Unfortunately, when it comes to strings, putting single quotes around a string and having single quotes within it, or double quotes, same thing, the only way to do this is manually, the only way that I've found. So the problem comes in, again, that people are just so much better at pattern recognition. We see this is a test here, okay? That's pretty obvious, and SQL sees it exactly the same way. But now let's put test in quotes. We understand that test is in quotes, and then the entire string is in quotes. But SQL doesn't see it that way. SQL sees it as this is a string. Test is some piece of code that we messed up and stuck in the middle, and then there's an empty string at the end. So in order to make it so that SQL can understand that, we have to manually replace all of those single quotes with double quotes. All right, all of the single quotes within the string. So this is the outside, this is the outside, and then this is a single quote, and this is a single quote. And in fact, if we print this, that's exactly what we're going to see. And you'll see this a lot of times, like here's an example of a name, George O'Malley. All right, if we don't remember to double up the quotes, then as far as SQL is concerned, Mally is, again, a piece of text. We have to put that extra quote here for it to understand that this is a string, that this is somebody's name, and it just happens to have a quote within it. Now, if we're working with brackets, then we can go into something called quote name. Quote name has two parameters. The first one is the string you're working with. The second one is what is the closing piece of the string that we want to use. So run this, and we've got a brackets around our string. And if we put strings in it, you'll notice now SQL has doubled that up, that closing bracket, so that it understands that this is in fact intended to be part of the string, in this case, a literal name. Without this, as far as SQL is concerned, this is the contents of the brackets of the literal, and this was a mistake. It doesn't know any better. It can't process any better than that. Now, you can pass in a second parameter, which in this case is a quote, and you can use that to escape a string. And in fact, sometimes you'll have to, but you're still going to have to double up the quotes manually. Okay? You're still going to have to go in and say, this is a test, in quotes, and go ahead and double up the quotes on either side of it. And you'll notice it's just a block of 4 of them here. One on the inside, one on the inside, one on the outside, and then doubled up in the middle to make a single quote. This does actually help some when you start getting into variables. So for example, the contents of this variable or of a column or field or whatever is this, and then we're going to print it out as if it's a string. I am a big fan of formatting. Formatting is maybe not essential, but when you're trying to maintain a piece of code, it's so much easier when it's well formatted, when it's readable. When you're working with Dynamic Sql, that's still the case. Your code still needs to be formatted, but there's an additional layer of formatting you need to have. So, for example, we've got this query here. Now, this isn't too bad to read, right? Well, so if I go ahead and set this up as Dynamic Sql, and I just throw quotes on either side and a plus, because that's not an uncommon way to do this, and then I print this out, that's not an easy thing to read, right? I mean, that's a bit of a pain, and if there's a bug in there, it's going to take you a little while to find it, potentially. So I can go ahead and put char13s at the end. And this is a common way to handle this. You'll notice the query is pretty well formatted. I can read it. If I run this and print it out, because again, remember, we've done a lot of printing and editing and pasting to see where our problems are. And this is essential when you're working with Dynamic Sql, to be able to read your code so that you can debug it. That's the whole point of printing it out. Now, while this works just fine, my personal preference is this right here, where I have a single quote at the beginning and a single quote at the end. The code doesn't format quite as nicely when you're talking about the actual code as opposed to the dynamic code. So for example, if I go ahead and take all this and tab it in a few times, for example, I've got it inside of a loop or a couple of if-else statements, whatever. When I go to print this out, you see what's happened is it's pushed over a bunch. So the formatting isn't quite as nice as you might like. So what you'll see in these cases sometimes is where these are tabbed over and the rest of it stays the same. And that doesn't quite look right either. So you just kind of got to make a decision how you want to format it, the way you want to handle it. Like I said, generally my preference is single tick at the beginning, single tick at the end. But as with all formatting things, it is personal preference. You do need to make it maintainable, though, because that person after you, when they start looking at your code, you do not want them cursing you. So there's this thing called a kitchen sink query, and sometimes called a catch-all query, frequently called, well, any number of curse words. And basically what's happening is you have a series of parameters, of values, and they can all be null, or some of them can be null. Any combination of them can be in use. And you'll see a couple of different patterns for writing these types of queries. First one, you'll have login name equals is null, variable field, and type equals is null, variable name field, and this works, okay? And it's a very simple pattern. It's easy to read, it's easy to understand. Problem is, indexes don't work. It's what's called a non-sargeable pattern. You can't use a search argument. Now, a better method is to say if the variable is null or the value, the field equals the variable. Put all that in parentheses and do the next one. That works, and it can use indexes. It's just not as efficient. It's not as fast as just writing a straight up query. So another option is to break it out using if then else statements. Okay, so we say if the type is null and the login is null and is disabled is null, and if the default database name is null, then we have one query. If all three are null except for default database name, we have another query. If is disabled is not null, but default database name is null, then we have another query. We do separate queries for each one. And this works, and it's fast, but it's kind of long. There's a lot of lines of code, and if you have to make a change, it could take quite a while. And you can see this is just 4 variables, a very short query, and it took 118 lines of code to write. And I got to tell you, when I was writing this, I made a lot of mistakes and had to go back and fix it a lot of times. It's more than a little bit of a pain. As I'm sure will surprise absolutely no one, the solution to this, or at least a solution, is to use Dynamic Sql. Now, again, this is a many-to-one. We're using multiple lines of code to create one line of SQL code. Well, one SQL query. Now, first thing we do is we make sure we've got a working SQL statement, then declare a variable and convert the code to string. This time it's going to be just a little bit different here. We've got our working piece of code, all right, but when we go to convert it to a string, we're only taking the select part, the from part, and any piece of the where clause that isn't changing, that's static. Now, I don't have that, so in this case, I'm going ahead and adding where 1 equals 1, because logically that's non-existent. It's null. It means every row. Now, the reason I do that, the reason I always make sure to add that if I don't have any other where clause, is because the next step is to add these lines of code here that add the login or the login name if the login variable is not empty. If type is not empty, then we add a type condition and so on and so forth. Okay. If I were to go ahead and skip this, then for each one of these, I'd have to check and see, is there a where clause already? And if not, this and has to be a where. And the logic on that gets a little complicated. It's far simpler to just go ahead and add this where 1 equals 1. All right, and then for each of these 4 conditions, I check to see, does the variable have data in it? And if so, add the condition. Variable data, condition, so on and so forth. And again, always print our output the first time because we want to check it, again, at every step possible. If we come over here and we paste it in, you will notice that I have my select and I have 2 conditions. That's because over here, I have a default value for type and a default value for is disabled. If I were to go ahead and add a default value for the database name, I should get a 3rd condition. And there we go. 3rd condition. Now, this is not going to run, obviously. I've got variables. So how do we handle this? This is what's called Parameterized Dynamic Sql. Okay, I have parameters. So obviously, if I have parameters, I have to have a way to pass them in. We do that using Execute Sql. Execute Sql has several sections of parameters. First thing we pass in is the SQL. Now, I want to point out this particular parameter, actually all the parameters you pass in, these first 2 at least, are Unicode or nvarchar, okay? They're Unicode. If they are not, it won't work right. So you have to declare them as Unicode, as having that N in front of them. And this one I'm not declaring, I'm just going ahead and putting it in. So I have to make sure I have that N in front of it. Okay? Now, query, and then my list of parameters. Then the list of variables that I'm passing into those parameters. If I change the name of this variable here, that's the one that's here. If I change right here, where it's a parameter into the query, that has to be changed here, where I'm defining my parameters. Clear as mud to everybody? And if we go ahead and run this, there we go. And I can, of course, get rid of this, and I'm going to get the same output, but let's just test it. And one last test, just to be certain. You want to play with these like any testing. Make sure that you test each of your parameters and a few combinations and that kind of thing. And like I said earlier, dynamic SQL is easy to break. Okay, this particular form is going to be a little harder to break. I'm honestly not quite sure off the top of my head what I could put in here. I guess if I changed this to a 1, that would break it, because that's not a nvarchar or not an nchar. It's a integer. But that's going to break anything. Now, sometimes you're going to want to double up here. Okay, you're going to have a kitchen sink query where you're going to be using parameterized dynamic SQL, but at the same time, you have a situation where you have to add the variable directly to the string. So here is a query that I've written that will give us all of the logins that are associated with AdventureWorks. All right? With the database AdventureWorks. And in this case, there's only the one of them. Now, if we come down here, I've got basically what I did before, all right, where I've got my login variable, my type variable, default database name is disabled, but I've added a database name variable, okay? Now, again, we've got our query put into a SQL string with a where clause of 1 equals 1. We check for the login, we check the type, we do this as parameterized Sql. All right, so now right down here we say, okay, well, if the database name is greater than 0, if we passed in a database name, then we want to go ahead and check to see if this login is part of this database. So one option, I've actually pre-written this stuff, unlike the rest of my stuff. One option is to go ahead and parameterize it just like we did before. Now, the problem with that is that this isn't valid. You can remember we talked about that in a previous slide. You can't put a variable as the name of the database. That just doesn't work. So we're going to have to actually construct that as part of the string. Now, this time, I've gone ahead and said, all right, if the database name has been passed in, go ahead and put it here. All right. Now, the problem is that if the database name is not a valid name, now we don't run a major risk of SQL injection because we are using quote name, but it's still not as good as if it was parameterized. Now, this will work. All right, we can print out the output right here. And we'll go ahead and throw it in another window so that we can go ahead and see what's going on. And, you know, we are going to select the SID from this database. Okay, that piece does work. The problem is, if I go ahead, we'll just go ahead and run it real quick. And again, we're using Execute Sql to run this. And it does work. Well, what happens if I go ahead and change the name of the variable or of the database that I'm passing in? All right, now we get an error. And we're trying to avoid errors, right? I mean, if we're doing this as part of some type of automation or some store procedure or whatever, we want to avoid someone being able to pass in a value that breaks our code. Now, the easy way to do that in this particular case is to throw a test to make sure, and we'll go ahead and throw it in right at the top, because honestly, there's no reason to do any work if this is wrong, that checks to say, that handles the error, okay? We're still not going to be able to run the code, obviously, but there's no point in doing the work, and I'd like to have a well-handled error. So we come down, we'll run this again, and this time, it's not even going to try and run it, it's just going to tell us that this particular database is not a valid database name. And we'll go ahead and fix it real quick and just make sure that it still works correctly if we have a valid database name. Because again, test with Dynamic Sql, and it does work. One of the easiest ways to avoid SQL injection is to use parameterized Dynamic Sql instead of constructing a string. So what you'll do is create your variables, create your command, but put variable names in it. Okay, just like you were creating a statement that you wanted it to work, where you wanted it to use these variables. Then you pass those variables into Execute Sql. You define them, you pass them in, and then when you run this, it's going to use the contents of those variables as, well, the contents of the variables. Clear as mud, right? Well, it's really not as complicated as it sounds. Execute Sql is actually creating a temporary store procedure. I don't know that the code is actually doing that, but to my mind, that's what it's doing. And if you look at it, we're creating a store procedure, and we're using the command that we passed in. See, add SQL was our first command, which is the query. The second parameter that we're passing in is the definition for the create procedure. Third piece is the variable declarations. And last but not least, we run the thing passing in our parameters, just like we would do here. Execute store procedure, passing in parameters. Now, doing it this way, using parameterized SQL, using Execute Sql, we completely avoid the risk of Sql injection because it doesn't matter what the name is that's passed in. It could be Robert semicolon select star from payroll. It doesn't matter because it's passed in to the query as a variable. So unless that happens to be somebody's name, they're just not going to get back any results. I do a lot of my coding in Management Studio, and there are a couple of settings that are pretty much essential for working with Dynamic SQL. I'm going to guess there are similar settings in Azure Data Studio and whatever other tools that you choose to work with. But basically, with your output as text, it needs to be as big as possible. That's for when we were going ahead and pulling the queries for each row, for each table. We were generating an alter statement for each table. You're going to do the same thing with results to grid. You can make it as big as you want, and in fact, it can be even bigger. And then on top of that, there is this retain carriage return line feed on copy or save that is also absolutely essential. Remember we talked about formatting, and if you don't have this, then your formatting is basically going to go completely away, and you're going to lose all those carriage returns and line feeds every time you copy and paste that to a new window to either run it or test your code. I did promise you homework. So to start with, take a look at the Little Bobby Tables comic. Yes, I know it's a comic, but it's pretty on target for this type of work, and it's worth taking a look at. Next, I've got a couple of white papers that you should, if not read, at least review. I've read both of them. They're great works on Dynamic SQL. I can't say enough about them. And last but not least, practice. This stuff requires a lot of practice to get it right, a lot of practice to avoid common pitfalls. Just work at it. It's not that bad once you've done it a few times. And thank you for coming. I hope you have a great rest of your virtual summit. We're going to do a Q&A next. And again, I hope you have a great day. And I did promise you a quiz, so here it is. Have fun.